P and Q are 2 points on the curve y equals 2x square. Fx equals 2x square. So if you look at the diagram, so you have P and Q 2 points on the curve, and obviously they are very close to one another. So you have P as x and Fx, and Q is x plus delta x, so slight increment delta x and Fx plus delta x. So you can see that QR is f of x plus delta x and minus fx, and of course PR is delta x. So then the question is saying that fx is 2x squared, so that's the equation of the curve, and fx plus delta x equals twice of x plus delta x whole square. The gradient of the chord is fx plus delta x minus fx divided by delta x. So they've given us the gradient, they've given us the equation of the curve, and now we have to show for part A that f of x plus delta x minus fx is 4x delta x plus 2 delta x square. So we try and work out part A first before moving on to the next two parts. So for part A, what would happen is, you see, you can write fx is 2x square and fx plus delta x is twice of x plus delta x whole square. So that's given to us. From here, what we do is we take one from the other. So fx plus delta x minus fx, if you subtract, it would be equal to twice of x plus delta x whole square minus 2x square. And then you expand the terms within the bracket, and you get 2x square plus 4x delta x plus delta x square minus 2x square, and the 2x square would cancel out, and you would be left with 4x delta x plus x square. So that is exactly what the question is saying, and we need to show. So that is done. Part A is done. The next thing, part B, is we need to show the gradient of the chord PQ is 4x plus 2 delta x. Now we know the gradient of the chord is y out of x, so it would be f of x plus delta x minus fx and divided by delta x. So we know that's the gradient. Okay, so now, and that's what they have given us as well. So now we have to prove that that is equal to 4x plus 2 delta x. So the start is, that's given also, and then we write from part A, we know that f of x plus delta x minus fx is 4x delta x plus 2 delta x square. So we just replace it, we put this here and leave the rest the same, so divided by delta x. So now you see that it becomes very easy. That would be 4x plus 2 delta x, and that's done. So for part C, we know that f dash x is limit x delta x tends to 0, fx plus delta x minus fx out of delta x. Okay, and this is called differentiation from first principle. So we will use that here. So we know that fx is 2x squared from first principles, and f dash x, therefore we can write the f dash x as limit delta x tends to 0, and then twice of that, instead of x we write x plus delta x, so that's whole square minus 2x squared divided by delta x. So that would give you this, simplifying, you get limit delta x tends to 0, 4x delta x plus 2x squared out of delta x, because your 2x squared and 2x squared get cancelled, and then you see that equals limit delta x tends to 0, 4x plus 2 delta x, and that is equal to 4x, and that is the answer, because delta x tends to 0. So this term will be 0, and we are left with 4x. So f dash x equals 4x. So that's how we've explained that from first principles you can see the same thing, that f dash x is 4x. So thank you so much for viewing. Thank you for your time, and please subscribe. And for more maths problem solving videos, please visit my channel at Hypatia Math 147. Thank you so much.